Hey, welcome back for Chapter 3. We are now going to be starting solutions of linear systems. And our first type of linear system we're going to look at is one where we have intersecting lines. So let me draw a couple lines on here. Here's our first line. And let me grab another color here. Okay, well, let me get another one and I'll change its color. There we go. All right, intersecting lines. Well, what do we know about intersecting lines? Well, they cross, they intersect, right? And so how many places do they intersect? Exactly one. So the solutions is the number of places where the lines intersect. If they intersect at exactly one location, how many solutions do you think there's going to be? Right, just one. So one solution. One solution. And if you were to take a wild guess what that solution would be, it is the point where the lines cross. Right there. Okay, so no matter what the system, if the lines cross, the point where they cross is the answer. It always has an x-coordinate and a y-coordinate. Okay, now let's take a look at coinciding lines. All right, so let me get a pair of coinciding lines on. So here we have a red line. And I'll use green. All right, I'm drawing this freehand. I'm not as good as the other way. Oh, that's bad. But maybe you get the point. One line is directly on top of the other. I think I'm going to use the line tool for the next line. Yeah, so every point on the red one is also on the green one. Coinciding means they are the same line. What they did is they took the equation and they multiplied every term in the equation by another number, like 2 or like 3. And if they multiply every term by another number, when you reduce things, you're going to get the exact same line. So how many solutions is that? Well, if every point on one equation is on the other, then you have what is called infinitely many solutions. All right, it's that way because every point on the first line is on the second line. Every one of them. Okay, now let's look at our third pair of lines. Alrighty, we're going to do parallel lines. So here's one. And let me get another one. Well, what do we know about parallel lines? Well, we know parallel lines have the same slope, right? Well, what else? We know they never cross either. And if the solution is the point where the lines cross, and the lines never cross, how many solutions can there be? That's right, there isn't any. So there's no solutions. Now, what if we were given equations of each of these lines? And we have to tell, without graphing, whether or not we have intersecting lines, coinciding lines, or parallel lines. What do you think we could do? Well, I'm not going to keep you in the dark too long. What you could do is solve for y. All right? If you put them in slope-intercept form, y equals mx plus b. What do we know about intersecting lines? Well, look at the slopes. they're going to have different slopes. So the ones with only one solution will have different slopes. So m will be a different number for both of them. Does it matter if b is the same? No, could be the same, could be different. If it's the same, it means they're going to cross at b, right? So different slopes. So if m is different, automatically you've got one solution and they're intersecting lines. Okay, well, what about the infinitely many? Well, since they're the same line, they will have the same slope and, a big and there, the same y-intercept. So what does that mean? It means that the m and the b are both the same. When you simplify it, solve for y, you get the exact same line. Nothing different. Every point on one line is on the other. What about the parallel lines? Well, we know parallel lines will have the same slope because they have the same slant. But look, this one crossed the y-axis down here. This one crossed the y-axis up there. So they will have different y-intercepts. So what does that mean? It means the m's are the same, but the b's are different. So different y-intercept. All right, there you have the lowdown on finding solutions of systems, whether you graph them or whether you don't. This is how you can tell which type of lines we have: intersecting, coinciding, or parallel. Have fun with these. Bye-bye.